to present about the portfolio of gas liquid separator. Our group member consists of 4 people, which is Ahmad Faruk Mubarok, Nadifa Andini, Anissa Chanadithias, and Mauludan Ruhardi Prakoso. Abstract. In this portfolio, we will be focused on vertical separator, specifically 3-phase vertical separator design with carbon steel material. For the vertical separator with mis-elimination that we used, the height was obtained at 13 feet and the operating pressure of 165 pse and operating temperature at 100 degrees Fahrenheit, and also mass center at total entropy at condition content of water, hydrocarbon liquid, and also hydrocarbon gas state in the PowerPoint.
Okay, so my name is Anissa Chandranites with student number 022119400000104, and today I will present the introduction of our report. So what is gas liquid separator? So gas liquid separator is a device used in an industrial application to separate a mixture of vapor or gas and liquid into its constituent phases. There are many kinds of gas liquid separator. This can include vertical, as you can see in this picture, and horizontal vessel, and can act as a 2-phase or a 3-phase separator. A gas liquid separator can also be referred to as a flash drum, brick pot, knockout drum or knockout pot, compressor suction drum, suction scrubber or compressor inlet drum, or fan scrubber. So there are several types of gas liquid separator. So gas liquid separators can be generally divided into 2 main groups: high gas to liquid ratio, for example, is knockout drum and scrubbers, and the other types is low gas to liquid ratio. For example, is oil gas separators and flash tank separator. In the aspect of the processed gas or vapor to liquid separator can be summed up as follows. First, conventional gas or liquid separators, including oil and gas separators. Then second was centrifugal gas or liquid separators. And the third one is gas liquid filter separators. So the types of gas liquid separators that is often used in the standard process are conventional gas or liquid separators. The second one is cyclones. The third one is oil gas separators. The fourth one is flare knockout drums. And the fifth one is filter separators. So for further information about this type of separators, you can see on the report. So for gas liquid separation is often based on the principle of gravity settling. When liquid droplets suspended in rising gas vapor settle down at the bottom of the separation vessel and are eventually taken out through the bottom. Gas stream separated from liquid is taken out from the top of the separation vessel. The separation of liquid droplets from vapor phase can be explained with the help of following equation for terminal velocity of liquid droplets. And the vapor phase density and viscosity are to be used for determining the Reynolds number. So the equation for volume and also the Reynolds number can be seen on this slide.
Thank you for the introduction. Next is methodology. I, Ahmad Faruk Mubarok, in RP 089 will be explaining it. First, calculate the vertical terminal velocity by using the following equation on the right. Afterward, calculate the K value by using one of the methods listed. And then, step number 2, calculate the vapor or gas volumetric flow rate. Wg is flow rate and rho is density of gas. Number 3 is to calculate the vessel internal diameter, di, if with a mis-eliminator at 36 inch, if not d is equal to di. Number 4, calculate the settling velocity or Vh of the heavy liquid out of the light liquid by using the following equation, with the mu being the light liquid viscosity. And then step number 5, do the same thing to calculate the rising velocity. Instead, the mu is the heavy liquid viscosity. Next, step number 6 is to calculate both light and heavy liquid volumetric flow rates by using this. And then step number 7, calculate the settling time for the heavy liquid droplet to settle through a distance of HL, height from liquid interface to light liquid nozzle, minimum of 1 feet, and the light liquid drops to rise through a distance of HH, hold up height with a minimum of 1 feet. Here is the equation. Next, step number 8, if there is a baffle plate, calculate the baffle plate area, which is the settling area for the light liquid, where A is pi d square over 4 and AD is the down cross-sectional area, can be found using the equation on the right, with G being baffle liquid load obtained from the figure below. Another way to find AD is written in the portfolio document. You can find it there. Step number 9, calculate the residence time of each phase based on the volume occupied by the light and heavy liquid phases. AH is equal to A. And note, if TRLL is less than TSHL or TRHL is less than TSLL, which implies that the liquid separation is controlling, the diameter needs to be increased, and then the procedure must be repeated from step 7. Step number 10 is to calculate the height of the light liquid above the outlet or hold-up height based on the required hold-up times. Note, compare this value to the one in step 8 and check whether the assumed value is reasonable. And then you need to calculate the surge height with minimum of 6 inch based on surge time if surge is not specified. The equations are on the right. And then last but not least, step number 11 is to calculate the vessel total height, although there are some guidelines that has to be followed. For all this type of H is listed over here, and for the guidelines, the minimum value of HA is assumed to be 6 inch, and HBN is equal to 0.5 dN plus greater of 2 feet or HS plus 0.5 feet. Here the N is the inlet or outlet vapor / liquid nozzle diameter in feet and can be calculated by using the equation on the right, where QM and M are the inlet mixture volumetric flow rate and density. HD is equal to 0.5 D or minimum of 3 feet plus 0.5 dN without miss eliminator or 2 feet plus 0.5 dN with miss eliminator. If a miss eliminator pad is used, additional height is required. The last step is to make sure that the ratio of HD over D is within a reasonable range, that is 1.5 to 6.0. That's all for the methodology. On to the next one, and thank you.
Hello, my name is Maulan Heradi Prakoso. I'm going to tell the details about the appendix. First, we determine the design pressure and temperature. We set the operating pressure is 165 psi, and we take 10% above the operating pressure. We can get 12.6 bar after we convert it, the operating pressure to bar. And we can get the operating temperature is 100 Fahrenheit. We determine the maximum, minimum, and min. And next, we use 2 millimeters for corrosion allowance. And then we use carbon steel semi-cube for the materials, and then we can determine the tensile strength based on the book. And then the fitted enter is 3 times 10 power 5 pound per hour. The component is contain water as heavy liquid, hydrocarbon liquid as light liquid, and hydrocarbon gas as vapor. And then we determine the liquid mixture density. We can get 56.7 pound per feet cubic. And then we calculate the vertical terminal velocity and K. For the K, we use two equations for auto edge short and GPSA. In this case, we use the auto edge short. So we can get the K is 0.313 feet per second. And then we can get the vertical terminal velocity. Next, we calculate the vapor volumetric rate. The vapor volumetric rate, we see this, we get the equation, and we get the value is 113.43 feet cubic per second. And then we determine the vessel internal diameter. We can get the value is 8.45 feet, but we round up to 8.5 to ease the calculation. And then we can get the settling velocity. Based on the table, we use KIS equal to 0.163, and we can get the settling velocity. And then for the rising velocity, use the same equation as the settling velocity. We can get 1.73 inch per minute. And then we determine the light and heavy liquid volumetric flow rate. We can get for the light is 1.85 feet cubic per minute, and for the heavy is 0.8 feet cubic per minute. And then for the settling time for the light, 6.94 minutes, and for the heavy is 5.773 minutes. And then we determine the bevel area. Before we determine the bevel area, we calculate the AD, and then we use the equation B for AD because the value is greater than the value of A. We can get the AL is 55.99 feet power 2. And then we calculate the residence time. We can get for the light liquid is 30.3 minutes, for the heavy 70 minutes. And then we determine the hold up height. We use TH equal to 25 minutes. We can get hold up height is 1.5 feet. For surge height, we can get 0.233 feet. And the last, we determine the total height of vessel. We can get the total height is 13 feet.
For the conclusion, Gas-liquid separation are the most essential gas-liquid separation that occurs in the oil and gas processing sector. The circumstance under which separation must take place and condition must be met. The efficiency of stage separation resulted in the maximum stability of the consequent phases as they exited the separator, like gas, oil, and water. The terminal settling velocities of the droplet in the separators rise as the pressure in the various stages of separator lowers. The rotation time of the vertical three-phase separator with the mixed structure was more than 100% higher than that of vertical separator without mixed structure. In addition, in vertical vessels without mixed structure, the search time was longer than in vertical vessel with mesh. As a result, the vertical separator with mesh are used for effective separation. That's all from Group 4, and thank you.